We invite our next speaker, Amos Bercovich from WSC Sports. He's a team leader. Or is it? Yeah. Okay. Amos has previously worked for Cortica, and he holds a master's degree in computer vision from Ben Gurion University at the Negev.
Hi all, happy to be here. So I would like to talk with you today about the process we did at WSC Sports for enabling game storytelling with zero or few shot event retrieval. So let's start with the World Cup final just a year ago. I'm sure most of you remember, it was a great game. Messi scored some amazing goals. Mbappe scored even more amazing. But if I want to tell the story of the game, would showing all the goals, showing all the key moments of the game, would that be enough? And as we see from the movies that our customers create, we see that in order to tell a good story, you need to show also where are we playing for, the venue, what are we playing for, showing the superstars of the team, preparing for the match, the lineups, obviously, and you can't do without the fairy tale ending, obviously. So all those footages around the game, we call them game story concepts, that they can happen before the game starts, during the game, or when the game ended. In order to tell good stories, you need to detect those footages, these concepts automatically. And yes, the bread and butter of the game highlights would be all the key moments of the game, all the goals, all the important events. And this is what we do at WSC for more than 10 years. We know how to develop dedicated models that understand the essence of the sport. And we can detect all the events, all the plays in football game, all the shots in a basketball game. We know how to trim those events. We know how to rank them and publish them everywhere during a live match. But we want to do more because we have a great highlight reel and we can produce all the best highlights of a certain player, let's say LeBron James, all his best plays in last month or whatever. But if we want to tell the story of the game, we need to enable those footages in order to implement them together with the key moments clips. But using the same tactic as we did for those action recognition model, using the same tactics with those game story concepts, it would be hard, first of all, because those concepts tend to have very large variance. They can appear totally different in different sports or different leagues, different broadcasting. And it will be kind of inefficient and costly because I have to train, maintain, and develop tons of different models. In addition, unlike those action recognition or play-by-play moments where I have to detect every important kick, every corner kick, every shot in basketball, in those footages, it's enough just to detect a good enough shot, meaning I don't need to detect all the moments where the players entered the stadium. I just need a good enough shot. Probably that will be the easiest one in order for me to detect it and integrate it in the video. So that leads us to a solution that should be simple for development, efficient because I'm going to use the same pipeline, the same backbone for all those concepts, and that will be a zero or few shot approach. So we introduced concept detector framework. Concept detector is a framework for event retrieval, and for supporting those large variants of concept, I want to tackle those concepts in two different modalities. First one would be a video retrieval from text, because I want natural language to describe the general essence of the concept, and video retrieval for images to copy specific appearances in specific broadcasters or specific leagues. So obviously, the backbone of this model would be clip, because clip can leverage the ability of using a natural language as a descriptor, And it worked really well for zero-shot tasks with images. But I want to utilize a clip for text retrieval from videos. So we decided to use the solution presented in a paper called Clip for Clip. In this paper, the authors examined 3 different types of video retrieval from text. And they showed that the most simple approach, which is just averaging the frame-wise embedding, give a powerful tool to do that. And we decided to take this approach. For video retrieval by images, we looked at a paper called Videogenic. And in Videogenic, they perform image-to-image retrieval by using gallery of images and then creating the average photograph by averaging the embeddings of the entire gallery. This reduces the effect of specific artifacts or specific particular persons or objects that can cause false alarm during inference. So now let's see how those 2 modalities combine together to one framework in inference. So we start with the full stream. We capture the full stream during a live game, and we extract 2 frames per second. Those frames go through the vision encoder, which is clip. Then we perform averaging, and we get the chunk representation vectors. The size of the chunk will be the size of the window of averaging. Now we can take every chunk and compare it to concepts that were prepared in advance. Actually, the comparison will be cosine similarity, as is used in clip. And then we perform thresholding of those scores, and then another weaker threshold to decide the start and the end time of a clip, which is longer than the chunk. Let's take a dive into the concept themselves. So as we said, each concept may have, but not necessarily, have 2 modalities. First one describing the global understanding of the concept, which is text prompts. In this case, soccer lineups or starting 11. And the visual modality, which holds the specifics, appearances of how they show in a specific league, which is MLS, how they show players lineup. And then all the images we create the average gallery vector, and all the text prompts, we stack them together. Let's take one concept as a case study. So we said even the easy development. So for detecting EuroLeague players lineups, that's the development you need. Just one text prompt and 2 images that describe how specifically players lineup are shown in EuroLeague. And if we look at the results of those 2 modalities, we can see that both of modalities detected the correct place of players lineup, but both of them have a false alarm. That kind of makes sense because this slide could be how they show players lineup in different broadcasters, and also the visual false alarm makes sense because visually it's kind of similar, but taking the intersection between those 2 modalities usually minimize false alarm drastically and gives you the desired results. Some insight that we gathered along the way. So we had to do some domain adaptation because professional broadcasting holds tons of cuts. And you have to make sure while averaging embeddings to avoid averaging frames from different scenes. Bias is a well-known problem in machine learning. So again, you have to make sure your galleries can cope with diversity. For example, we had problems when moving concepts from basketball men's league to basketball women's league. Audio is another great signal that can be easily implemented in this framework. So for summary, we presented a concept detector, which is a framework for easy development of concepts that appear around the game. And this is like few examples of the concept that we developed in the last 6 months, and we already integrate them in our game stories with our customers. I want to finish with a shout out for the team that made it all happen, did a great job. Thanks for listening.